Heat is nothing but the total amount of energy which a substance produces. So in Fahrenheit scale, the melting point of ice is said to be 32 degree Fahrenheit. There is expansion in the dimension of solid when a heat is supplied. So lengthwise, if there is a change in a solid, then it is said to be a linear expansion. Hello everyone, I'm Brinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 1 of a new chapter, that is chapter 11, and chapter's name is Thermal Properties of Matter. So in today's class, let us study regarding the heat as well as temperature, that is the basic concepts of the thermal properties. So here, heat and temperature. So usually in our daily life, we experience heat and temperature, wherein this heat and temperature are the same concepts which are related to each other, but there is a slight difference in it. So what is meant by a heat and a temperature? So here there are two diagrams wherein you can see one is representing a heat of a water, another one is representing a boiling, that is the temperature of a water. So what is meant by heat? Heat is nothing but the total amount of energy which a substance produces. Okay. So what is heat? Heat is nothing but the total amount of energy which is produced by a substance. Wherein what is temperature? Temperature, it is the measure of hotness or a coolness of a body. That is, it is the molecular vibrations of the particles which is present in a liquid or in a fluid or in a matter. So it is a vibration which is present in the molecules. That is, the energy of each molecules within a substance is said to be the temperature, and the total amount of a liquid or a matter, that is the total amount of energy which is produced by a substance, is said to be heat. So that is all about your heat and temperature, wherein two are calculated in different manner. That is, heat, it is a form of energy which can be transformed from one form to the other form. Correct? So the heat is the one which is present in your mouth, and when you place your thermometer, what happens? The energy is transferred from mouth to the thermometer, but there is no addition or deletion of energy. So it is calculated by the SI unit, and that SI unit is said to be in terms of joule. When in case of temperature, the SI unit is said to be represented in Kelvin, which is represented as capital letter K. So that is all about your heat as well as temperature. Now let us go to the measurement of temperature. How do you measure a temperature? So temperature is measured by an instrument, and that instrument is given in this image which you have already seen in hospitals and all. So this is nothing but the one which check the temperature, and the name is thermometer. So thermometer is the one which is used to check the temperature. So in case of thermometer, nowadays, you have got the digital thermometer as well. So there are types of thermometer of different scales. These scales are there, no? These divisions are with the different scales. So according to the types of the values, that is the type of the scale, the thermometer is divided into three parts. That is Fahrenheit thermometer and Celsius scale, that is the one which gives in Celsius, that the temperature is given in Celsius, and the next one is the temperature which is given in Kelvin. So there are three scaled thermometer: Fahrenheit, Celsius as well as Kelvin. So that is all about the instrument which we use to measure the temperature. So now we have, in case of measurement of temperature, the melting point of ice. We know the solid, liquid and gaseous state. So after which the melting point of, that is the ice melts, is after 0 degrees Celsius. So 0 degrees Celsius is the one, it is the specific degree, that is the specific temperature of the melting point. So melting point of ice from which the ice starts melting is said to be 0 degrees Celsius. Melting point of ice is 0 degrees Celsius. Similarly, the boiling point of water, the ice is said to be boiled. So ice, as the temperature increases, as the heat is produced to ice, what happens to the ice? From 0 degrees Celsius, it starts melting down. It becomes a liquid in certain degrees Celsius, after which there is furthermore increase in heat. That is, the heat is produced to it. When the heat is produced to the same liquid, what happens to the liquid? It starts boiling. Until where it starts boiling? Until it exceeds certain point, that is the boiling point, after which it starts vaporizing. So what is this boiling point of water? It is the high point wherein the water starts boiling, after which it is reduced to vapor, that is, it vaporizes. So boiling point of water is said to be 100 degrees Celsius. So how this is identified? By using a temperature scale, that is thermometer. These are in degree Celsius. So the melting in degrees Celsius, that is in thermometer of the Celsius scale, it tends from 0 to 100 degrees Celsius, and each is divided into 100 equal parts, that is 100 equal centigrade. Each is of 1 centigrade. So that is all about your Celsius scale. In Fahrenheit scale, now we are talking about Fahrenheit. Earlier we were talking about the Celsius scale. So in Fahrenheit scale, the melting point of ice is said to be 32 degree Fahrenheit. So we have 32 degree Fahrenheit. F tends to Fahrenheit scale. So from 32 degree Fahrenheit, and the boiling point of water is said to be 212 degree Fahrenheit. 212 degree Fahrenheit, which is equal to the same Celsius scale. Both the values are equal, but the values which is shown here is different. So it is divided into how many equal parts? It is 180 equal intervals. So that is the degrees which is present in Fahrenheit scale it is divided into 180 equal intervals. So that is all about your temperature scale. The one which you use in order to find the temperature is thermometer, out of which you have studied 3 types of thermometer, under which you have studied melting point of ice and boiling point of water in Celsius scale, melting point of ice in Fahrenheit scale, and boiling point of water in Fahrenheit scale. And you got to know for how many equal intervals both are divided. So that is all about your measurement of temperature. Now let us go to absolute temperature. So absolute scale of temperature. So now there were an experiment which was conducted in which the volume of a gas was said to be constant. Change in pressure of the gas was determined. That is, it is used to determine the temperature. So when there is change in pressure, we determine the temperature with a constant volume. So with that we got a curve, that is Tc. This is the temperature. This is T in degrees Celsius, which can be determined by Tc, and here it is P to T, which gives you the temperature as well as pressure curve. So when that is the case, you have got a linearly varying line. So here it is like, it shows the pressure in the bath varies linearly with the critical temperature. So the pressure of the gas varies linearly with the temperature. So when you extrapolate, this is the extrapolated lines. When you extrapolate, that means an imaginary line is drawn along the line itself, which meets at the negative x-axis x dash, and the value which is present over here is said to be minus 273 degrees Celsius, which is given as minus 273.15 degree Celsius. So that is the value which we have got. Okay, so considering this value, when extrapolated, whatever value you have got is minus 273.15, considering that, you can give it as that is at constant volume, the pressure of the gas what you have taken becomes 0. Okay, so it is like at constant volume, the volume is kept constant. At this constant volume, the pressure of the gas, whatever you have taken, is 0. And that is at which temperature? That temperature is minus 273.15 degrees Celsius. So you can conclude it as, at this temperature, that is minus 273.15 degrees Celsius, the pressure becomes 0 at constant volume. So such kind of a temperature is said to be absolute scale of what? Temperature, because it is in degrees Celsius, and Celsius is the SI unit of temperature. So it is given as the absolute value of temperature. So that is all about your absolute scale of temperature. And the temperature scale, it is based on absolute 0. Since it is based on absolute 0, it is known as absolute temperature. So that is all about this concept. Now, having these concepts, let us move to the thermal expansions. That is, when the heat is produced to any object which is present anywhere, that is in the surroundings, what happens to the object? It expands. The heat is produced for an object to expand. Okay, so the same experiment is conducted over here for us to understand how the property of substance change in accordance with the supply of heat. So here it is, there is increase in dimensions of a body. So there is increase, the dimensions, that is length, breadth, height, volume, all these are the dimensions. So these dimensions of the body starts increasing when the heat is supplied to it. For example, there was an experiment which was conducted, so which is given over here in this image. That is, you have a stand which is connected to a chain-like structure, below which it is suspended by a cold metal ball. Okay, so the metal ball is suspended from this stand, and there is a presence of a ring which is large enough. So this is the initial condition before heating the ball, that is the metal ball. So once the heat is produced, that is the heat is applied on this ball, what happens to this metal ball? It starts bulging up, that is the expansion takes place in its dimensions, and that was proved by this experiment. It is the same experiment, but this was before heating and this was after heating. After heating, the same ball was allowed to move within the ring, but it stopped there only, which implies that there is expansion in the dimension of solid when a heat is supplied. So there was no heat, it passed through the string. There was heat, it is not able to pass through the string. So there is an expansion. So this thermal expansion, that is thermal expansion, is nothing but the change in its dimensions once the heat is supplied to it. It is divided into three types, that is either it changes by length, or else its area changes when heat is produced, or else its volume changes. So these three concepts have got different kinds of expansion, that is the names. So here let us study about the thermal expansion in solids. So which are the components in thermal expansion of solids are, we have got linear expansion and area expansion. So what is meant by linear? Linear means it is a line, that means it's a length. So lengthwise, if there is a change in a solid, then it is said to be a linear expansion. So here linear expansion means there is increase in the length of the body. Lengthwise there is a change in the sense it is always increase and not decrease, because the term itself says expansion. Something is getting expanded. That is, for the original length or original item, something is getting added more. So that is called as expansion, vast, expanding. So here linear expansion means the length is said to be increased than that of the original length when a temperature is increased in a body. That means when a heat is supplied to a body. So that is all about your linear expansion. And when you come to area expansion, that means the same thing, area is expanding, that is adding up of extra area. So here the increase in the area of the body when there is increase in temperature. How there is increase in temperature? When a heat is supplied to an substance or an object. So here we have got your linear expansion and area expansion. So when you consider this image, this is one of an example for the expansions of the bodies, that is the expansion of objects that is given thermally. So there is a dent over here, that is a bending is given for a railway tracks, which uses this thermal expansion concepts. So here ends your thermal expansion in solid, after which we are going to study the coefficient of thermal expansion. So what is meant by the coefficient of thermal expansion means we have studied the expansion linearly, area expanding as well as volume expanding. So linear expansion, area expansion and volume expansion, three expansions are having its own coefficients, which is given by alpha, beta and gamma. So it is termed by alpha, this is termed by beta and volume expansion is termed by gamma. So increase in length per unit length is said to be the linear expansion. Similarly, increase in area per unit area is said to be area expansion, and volume expansion is increase in volume per unit volume. So how can you give this alpha, beta and gamma? That is by considering linear expansion, which is given as linear expansion, area expansion and volume expansion. So we have got three types of expansion, that is linear expansion, area expansion and volume expansion. So in linear expansion we have got it as there is length L at time t and the change in length, that is expanding, so something is added up. Change in length is done when the temperature is increased. Okay, so when this is a case, you have got it as L, that is the change in length per unit length when there is change in temperature, which can be given as alpha is equal to change in length per unit length when time is, that is for delta t. So alpha becomes delta L divided by L into delta t. So this becomes the coefficient of linear expansion. Similar is applied to area expansion. So there is area A before the object is subjected to heat, area A, just A when temperature is T. Next, when there is change in area, you have A plus delta A when there is change in temperature. And now delta A, that is change in area per unit area at the change in temperature, can be given as beta, which is said to be the coefficient of area expansion. So delta A by A into delta T. So this can be the coefficient of area expansion. Next is it is volume expansion. In case of volume, the same thing applies. V is at T and there is V plus delta V for the change in temperature T plus delta T. So when this is a case, change in volume, that is change in volume per unit volume at temperature is given by gamma, which is equal to delta V divided by V into delta T. So this can be the formula, that is coefficient for volume expansion. So you have got three coefficients for linear expansion, area expansion as well as volume expansion. So for linear, area and volume expansion, there is a small relation, and that relation is given by alpha is equal to beta by 2 is equal to gamma by 3. So this is the relation between the three coefficients, that is the linear expansion coefficient, area expansion coefficient as well as volume expansion coefficient, wherein alpha, beta, gamma. Alpha represents the coefficient of linear expansion, beta represents the coefficient of area expansion, and gamma represents the coefficient of volume expansion. So in today's class, we have studied what is meant by heat, what is meant by temperature, and what is that difference between temperature as well as heat, and the instrument which is used to measure the temperature, that is the thermometer. And in that case, it is nothing but when you're converting, if you want to convert your degree Celsius any value to Kelvin, which is a standard SI unit of temperature, Kelvin, whenever you want to convert it to standard temperature, that is the Kelvin scale, that is the SI unit of temperature, you will have to add with the absolute temperature, that is any value of Celsius plus the absolute temperature, which is nothing but 273.15, that is minus 273.15. Any value plus 273.15, your temperature is converted to Kelvin. So that is all about your measurement of temperature using the thermometer. So after which we have studied regarding the expansion of solids, wherein you are elaborating three types of expansions, out of which you have given the coefficients of expansion. So in next class, let us study further about the thermal properties of matter. Until then, have a good day. Thank you.